Good morning, friends. Good morning, friends. In this class, we are going to discuss about imperfections or defects in crystals or lattice. In previous class, we already discussed what is a crystal, what is a unit cell, what is a space lattice, what are 14 types of Bravais lattice, each and everything we discussed. Especially don't confuse about this metallurgy and material science. No doubt, I told you in the several times, it is a theoretical subject. It is a completely theoretical subject, but be familiar with your figures or diagrams. Once you list out the definition carefully, once what is a space lattice, what is a unit cell, if you define properly and list out draw the figures carefully, and if you elaborate, marks will be given to you. But don't confuse about the theoretical subject. And if you please be perfect with definitions, please be perfect with figures. Okay, be perfect with your figures and definitions, and then the subject will be very easy to you. Practice the figures carefully. We already discussed what is lattice, what is the crystal structure, what is the in this crystal, what is the unit cell, what is the include angle of alpha, beta and gamma. These things we already discussed. So if you have any doubt, ask me. I will provide you. I already given you material. If you have any difficulty, please ask me. Don't feel any bit nervous or any bit in difficulty. Please contact me, or please you can put it your problems regarding. You can contact me directly. Don't panic about this subject. Before the examination, I am going to complete each and every topic because the time is very short. I'm giving each and everything very legible and clearly. Also try to concentrate on the subject in this class. Mainly in this class, we are going to discuss about imperfections or defects in crystals or lattice. These are, so imperfections means what are the defects in crystals. See, if at all, so in solids, the atoms we already discussed. In solids, the atoms are very closely stick to each other. That's why the bond between in solids, the bonding is very near to each other. That's why it was very strong and rigid. Whereas in liquids, the atoms, the gap between the two atoms is a little bit large. In gases, it will be more large. In liquids, it is less, and gases it will be more. So whereas in solids, the atoms are closely packed to each other. That's why the bonding will be very solid. Okay, whereas and in that solid also some atoms may vibrate and some atoms may not be in that same position. Okay, suppose these things we are going to discuss. Why? Because if it is that solid, even though it is a solid structure, suppose in copper or any suppose brass, if you heat it, the properties may change. If it is subjected to some heat treatment process, copper, brass, gold, these things, if you subject it to some heat treatment process, the properties may change. Okay, so if at all the mechanical or electrical or chemical properties may change, they may have some imperfections. In this class, we are going to discuss what are imperfections. So mainly these imperfections are classified into 4 types: lattice vibrations or phonons, point defects or zero-dimensional defects, line defects or one-dimensional defect, planar or surface defects. Okay, planar or surface defects. Okay, mainly in this class we are going to cover these 3: lattice and point and line defects. With time, these things we will discuss in the grain size, grain and grain boundaries. We will discuss in the next class. So what are lattice vibrations in an atom? So in a solid, atoms may vibrate in it about its regular mean positions. So I already told you, if at all it is a brass or copper or some other any metal items, when subjected to heat treatment process, the properties may change. So lattice vibrations means the atoms may vibrate about the mean positions. Okay, so thereby it causes some deviations about that mean positions. Okay, so in this, if the atoms may vibrate about its mean positions or regularly or irregularly, thereby having some vibrations in that system. Okay, so these are the things. It may cause affect also, it may cause impact also on that metal item. Okay, so don't be confused. It is a some vibrations takes place. Some vibrations takes place about its main portion. Coming to point defects. Point defects is, this is important one. Point defects important one. In this you are going to study what is vacancy and what are the self-interstitial and other defects, self-interstitial and interstitial defects. Interstitial defects. Already told you, be careful about figures. If you represent these figures carefully, and so regarding this online class, and I am teaching on this whiteboard. If so, go through this figure carefully. Go through this figure carefully. So these are point defects. These are point defects. Point defects. So imagine this is one crystal structure, one atom. So here imagine this is one atom having one structure of atom having atoms are present in this crystal. So if you observe carefully, one atom is missing from its regular site. One atom is missing from its regular site. So that is called a vacancy of point defect. So no need to by heart or no need to draw the figures carefully, listen carefully. Automatically you can you can write on your own. But regarding definitions as per the book and regarding the figures, these figures are from your textbook only, from Kotger, Dr. V. Kotger textbook, Metallurgy and Material Science by Kotger textbook. Go through this book. So in this point defect, one atom is missing from its regular site, then it is called a vacancy. A vacancy. Okay. So point defects are nothing but point defects. In this point defects also you are going to study. So almost 4 types point defects. Okay. So point defects. So look at carefully. Point defects. One atom is missing from its regular site, then it is called a point defect. So coming to this interstitial and self-interstitial. Okay, what is meant by interstitial impurity and what is meant by self-interstitial impurity? Okay, here also if we observe this figure, the atoms are ordered regularly. Here in self-interstitial impurity, here also the atoms are ordered regularly. Okay, ordered regularly, but one of the atom is means some the size is decreased. Okay, from the atom is decreased, the size of the atom is decreased. Okay, so whereas self-interstitial, all atoms of same type, but one other than the parent atom, other than the original material of the original composition of the atom is included in this structure, of atoms. Thereby it is called a self-interstitial impurity. Okay, if the atom is missing from its regular site, don't confuse, it is a vacancy. If the atoms are in regular order and the impurity means a foreign impurity is bombarded, means the size of the parent atom is decreased, then it is called as the interstitial impurity. Okay, whereas in self-interstitial impurity, the matrix atom occupies own interstitial site. Okay, matrix atom occupies own interstitial site. Okay, it is so if you observe this figure, all are of the same type, but this is having some different color. Okay, here it is black and white structure, then it is a black and white figure. But if you observe carefully, the color of this atom may change. It will appear, if you observe carefully, the color of this atom may change. Okay, so if it is the interstitial impurity atom it is also the order of the atoms, the order of this structure is also differ. Okay, here all the atoms are arranged in regular pattern of atoms, whereas here the atoms may not be in the same pattern of atoms. Okay, whereas if you look this substitutional impurity, here all the atoms are arranged in regular pattern, okay, but one in substitute is takes place, okay, so thereby it is called substitutional impurity. So if you look at the figure, it will be easy to recollect and reproduce, okay. So here the atoms are arranged regularly inside, one atom is missing. If here also a substitutional impurity atom, all the atoms are arranged in regular pattern of atoms and one substitutional impurity is added to this side, then it is called as a substitutional impurity. Here the order structure is may not be same and some foreign impurity, foreign atom of its own side may added to this regular set, then it is called as self-institutional. Interstitial impurity means one, it is a interstitial impurity means it is it occupies interstitial site of the matrix. So don't confuse here, it is of substitutional impurity means it is one for here also the atoms are may not be in regular pattern and the order of its own side, and interstitial impurity means one foreign atom is added to this, okay. So these are the main defects of the point defects. Mainly what is vacancy, what is interstitial impurity, what is self-interstitial impurity, and what is substitutional impurity. I told you in the beginning, it is a total theoretical subject, okay, completely theoretical subject. So be concentrate on the figures. If you reproduce the figures, it will be sufficient to you, okay. And definitions, regarding definitions as per the textbook, okay. So don't confuse, okay. Next one, I told you better purchase on if you have diploma students. I think you studied in your diploma, but regarding the intermediate student, better go through some book, or if you download the material, it will be sufficient. Better go through the material which I am going to give to you, okay. Go through the material. If you have any difficulty, ask me, because the time is very short. Regarding the first mid exams are approaching, here I am doing my best. Go through the book. And next one is line defect. What are line defects? Line defects are nothing but it is also one structure of atoms. Whereas here, if you see this figure, line defects are again mainly two types: edge dislocation and screw dislocation. Okay, edge dislocation and line defects are divided into two types. Okay, why? Because see, I told you in the beginning regarding that structure of atom, that three-dimensional structure, na? This three-dimensional structure. This one. If you cut this one unit cell, I think I told you in the beginning, cut one unit cell. Okay. Anyway, line defects are again divided into two types. This one is edge dislocation. So edge dislocation is nothing but here the atoms are missing from the regular sides. Here what happens? Here the structure. Look at this figure. This one is line defects. In this line defects there are two types: edge dislocation and screw dislocation. Here see this one, atoms are regularly connected to each other, but whereas here the link is missing. Okay, here the link is missing from its regular side. Okay, so this type of structure is called edge dislocation. Okay, here the atom is missing from the link of directly. Okay, so here no atoms. Okay, so then this type of dislocation or defect is called edge dislocation. So if it is positive dislocation, it is denoted by inverted T. If it is negative dislocation, it is denoted as T. Here what? Here see, here it is a positive dislocation. Here it is a positive dislocation. If it is negative dislocation, it is in T structure. Don't confuse, okay? Here, if you observe these things, here it is a positive dislocation. Inverted T. Inverted T means it is a positive dislocation. If it is T structure, you get a negative dislocation. Okay. Now, what is screw dislocation? Imagine you are going to cut one cake. You cut one cake with a chalk. So suppose here also one layer is, if you are removing one layer, if you are removing one particular layer in such a way that this part is here and again this part is here. Okay, imagine a three-dimensional figure. If you are cutting a cake in such a way, if you are cutting a cake in such a way, then it is called a screw dislocation. Okay, means if you are cut one cake, if you cut one cake, I think the figure is clear to you. Okay, if you cut this cake, okay, here it is a three-dimensional structure. Okay, three-dimensional structure. So the corresponding, the vector, if you draw the edge dislocation and screw dislocation, so imagine it is a three-dimensional structure. So Burger's vector, it is called as Burger's vector. Okay, so the link between the screw dislocation to edge dislocation, if you draw vector, or if you want to replace the vector, it is called as Burger's vector. Okay, so don't confuse. If here edge dislocation is nothing but atoms are missing from its regular side, okay, then it is form of inverted T, then it is called a positive edge dislocation. If you imagine you are going to cut one cake in such a way that part of the layer is removed, then it is called screw dislocation. Then it is called a screw dislocation. Okay. So these are point defects. I think the figure is clear to you. Okay. Atom is missing from its regular site. Then the defect or the imperfection is called vacancy. Here, one substitutional impurity is added to its regular site, then it's called a substitutional impurity. Okay, I think all of you have the figure is very clear to you. Okay, so look at the figure thoroughly, carefully, observe the figure carefully. Okay, all of you go through this figure carefully. So what is meant by interstitial impurity? Here also atoms are arranged regularly in the atom. So one of its own site, atom of its one of its own site is added to this, then it's called an interstitial impurity. Here also self-interstitial, the atom may not be in a regular pattern, but the size of the interstitial atom, some foreign atom, some impurity is added to this site. Here, if you observe these things, self-interstitial is small, here also substitutional impurity is small, but interstitial impurity and substitutional impurity is small, whereas self-interstitial impurity is more, means the size is somewhat more. Okay, so observe carefully. These Frankel defects are discussed in the later class. Next one, planar defects. In the planar or surface defects, we are going to study about grain size, grain boundaries, all these things we are going to study. Okay, don't panic. First go through the metallurgy and materials. I told you in the beginning, it is completely a theoretical subject. So if at all thermodynamics, applied thermodynamics, or fluid mechanics, or hydraulic machinery, or some mechanics of solid, these are some problematic. So once you study the problem derivative or definition and go through the problems, then it will be journey will be different. But here it is completely theoretical subject, total theoretical subject. You have to practice carefully. Okay, why? Because writing theory of 3 hours, writing theory exam for 3 hours is not an easy exam. Most of the students feel difficulty or boring about this subject. Why? Because all the time theory, but these topics are new topics to you. If you go through that these steel plant, metallurgy, some metallurgical labs, some blast furnace, and if you go through if you join in jobs, then these subject and applications will be involved in their steel plant or some NSTL okay, national some industries. These are the application there you are going to find. So blast furnace, what are the cupola, all these things you are going to study there. You are going to do practically there. But here you are going to study theoretically, unless theoretical concept is differ with practical approach. So if you study theory and do practical, then it will be a much more full use to you. But be patient, because now is the pandemic time. Because of the pandemic time, you are at home and I am here. We are going. I am giving classes through online, and that it is a theoretical subject. So I am giving my notes best to you. Go through the notes, and I am giving figures to you. Okay, I will explain. If you feel any difficulty, I will explain further if time permits. But be patient. Be patient. Why? Because if you feel any problems regarding metallurgy or applied thermodynamics, directly you can contact to me. Okay. So the basic thing for this metallurgy and material science, you have to be perfect with your definitions. You have to be perfect with your figures. Okay. Regarding theoretical subject, once you read twice or thrice, and you can write it on your own. But be perfect with your definition, unit cells, space lattice, what is Brave's lattice, what are the types of defects. These, recollect this, remember these 4 defects or imperfections in crystals or lattice. Remember these 4 defects: lattice vibrations, point defects, line defects, planar defect. Then you can draw these figures and explain in point. You can explain on your own. Lattice vibrations, atoms in solids are may not be in a regular position. They can vibrate. Okay, they can vibrate about its mean position. Okay, thereby some caused vibrations caused are known as lattice vibrations. Next, point defects. In point defects, if its atom is missing from its regular side, then it's called, the defect is called vacancy. And next, interstitial impurity, self-interstitial impurity, substitutional impurity, and again line defects. What are line defects? There are 2 types of line defects: edge dislocation and screw dislocation. Regarding planar or surface defects, I am going to discuss in next class. Why? Because it is a separate topic. In this, we are going to study about grain boundaries. Okay, grain boundaries and grain size. These 2 topics I will discuss in the next class. I am going through giving the material, but don't be panic regarding metallurgy or material science. Okay, I am giving my material to you, best to you. Be perfect with the definitions and figures. And in the very important, in the examination, you are supposed to draw with, use your scale and pencil, because in the university exam, marks will be allotted only if you draw with scale and pencil only. Okay, thank you.